Today we're going to go over accelerating search with TIBCO LogLogic Log Management Intelligence 6.1. We're going to start off the day with a demo which compares our new advanced search with that of our legacy regular expression search. We're going to show how we're able to vastly improve the performance of regular expression searches and searches in general when compared to our legacy regular expression search interface. Then we'll briefly go into how we were able to accomplish these results. So let's go ahead and move over to our search interface. So this is our new advanced search interface. You'll notice that this window I'm on one IP address, and in this window I'm in the same exact IP address. All I'm doing here is showing a side-by-side comparison between our legacy regular expression search and that of our new advanced search. Our new advanced search allows a user to combine the power of regular expression searches with that of index searches. This allows for a more efficient and powerful search. And when we compare this with the advanced, when we compare the advanced search with that of our brute force regular expression search, you'll find out, and we'll show this here in a minute, how much faster the results come back. So let's quickly start off with explaining what we've got here. So what I've done is I've loaded up World Cup data, which is W3C formatted log data. It's this data that spans a course of a year. This data is real data. We've gotten it off the internet from a World Cup that was a couple years ago. What I'm going to do is I'm going to run this EQL advanced search lane query, which is going to essentially run a regular expression search across the index values. So what this does is we hit the indexes first, looking for these IP addresses here in the query. We quickly return the result set for those matches, and then we apply the regular expressions on top of that. That allows for a very fast and efficient search. When in comparison, when we go over here to the regular expression search, which is our legacy brute force way of doing things, which is very similar to how every other technology in the industry does regular expression searches as well, is where it just simply takes a regular expression, like in this example here. It's basically ORing the set of 3 IP addresses. We're going to run this search back over the course of a year. So let's set the time buckets up. All right. And then we'll go ahead and run this up. So we'll kick that one off there. It's in the chute. We'll go ahead, come over here. We'll run this one for the course of a year. There we go. There we go. Less than a second, we came back with results. Whereas this one is still chugging away at only 25% of the way through. Again, the new advanced search is much powerful and much more efficient in what it does when it's, again, hitting the indexes and then returning the result set back to the regular expression engine so that it can then process a smaller result set rather than in a traditional way of brute force where it has to basically analyze every single log message and find a match. So while that's going on, let's go ahead and set up another demo here. So we'll go through this example here. And what this is essentially again, what I'm showing you here is what we call a filter block. And a filter block is essentially just a shortcut for saved queries. So you can basically take complex queries like you see here where we're searching for Active Directory event IDs and we're just ORing them together. We can save that into a filter block and then we can just call the filter block in the query language. This allows you to build complex queries without having to type the full syntax out. So let's see. So okay, that one's done. We'll go ahead and we'll load up a similar search here and we'll do the comparison. So again, what we're comparing here is, in this example, we are going to search for the event IDs in an OR, and this is just going to use straight index. It's going to be, again, it's going to hit the indexes, look for the values that find a match, and then bring the result sets back. The same exact query here, which is done through regular expression ORs, will also be done. So we'll go ahead and set this up to run back the course of a year. Set our time buckets up. Alright, so we'll run that. It's in the queue. We'll come back here, run this one for the course of a year, and kick it off. And now it's hitting the indexes, and there we go. So results start coming in. a little over 3 seconds, whereas this one's still going, and you can see it's only 29% all the way through. So again, vastly faster, much more efficient, much more powerful. Let's take a look at another example. So in this example here, we're going to search for a event ID 4647 followed by a space and a string for Microsoft Windows security auditing. And we're going to look for this as 2 indexes tokens, an event ID and a string. Again, the way it's going to work is we're going to hit the indexes first, find our token matches, bring the result set back, and then apply the regular expression on top of the result sets. Again, because the result sets will be vastly smaller than having to open up and look at every single log and process the regular expression on top of that, it allows us to be very fast and efficient. This also allows us to be more precise in our searches because while the indexes may find a match or a partial match, at least the regular expressions can then refine that. So let's go ahead and take a look at the similar regular expression search here in the legacy report. So we'll load that up. So again, here we go. We're looking for an insensitive match for an event ID followed by a number of spaces and the string. So let's go ahead and run that back. Well, again, let's set the data up, run it back for a course of a year, set our time bucket up. And we'll go ahead and run it. There we go. It's in the chute. Let's go ahead, execute this one. Now let's hit the indexes, return the result sets, and there we go, a little over 5 seconds. This one completed. There we go. So again, almost on par. Let's take a look at another one. So let's load up another example here, and this will be our last example, and then we'll get into the slides for explaining how we're able to do this. All right, so let's see here. We're going to run another search. So let's take a look at our next example here. So we're going to head and we're going to run a search here. And what this one's going to look for here is the event ID 4625 in a regular expression search followed by a string for SA_admin. So again, it's another regular expression search. And in this example, we're not going to be really concerned with speed comparison, but I wanted to show you like kind of the accuracy when running the regular expression search when compared to and over the brute force way of doing things in the regular expression search here. So depending on how your regular expressions are written, things can be you know, a little loose, so not as accurate. So let's go ahead and take a look at this one. So again, it's the same search here. More or less, this is a regular expression. This is using the combination of the power of regex and that of index. We're actually just going to run this over the course of a year here. There we go. It's loaded. We'll go ahead and run that back for the last hour. I'm sorry, I think I said a year. This is actually just for the past hour. So there we go. So again, this is just the past hour. We have 500 results, and compared to we have 334. So here again, I'm just showing the example here where I have highlighted. You can see here we've got this FA underscore. So it's not quite SA underscore. So the regular expression overmatched. So when we use the combination of the advanced search in its method of doing things, we get a more precise search. So again, a more precise search, a more powerful search, and a faster search result sets come from our new advanced search feature, whereas in comparison to, you know, the industry way of doing brute force way, like our traditional way in the legacy regular expression search, is vastly different, and the advanced search is way more powerful and faster. So let's take a look now at how this is accomplished. So how did we do it? First, let's take a look at understanding some things. So faster search. So searches across huge amounts of log data using the brute force regular expressions can take a long time, and that's what we kind of saw there in the legacy report for the regular expressions. So to accelerate them, LMI uses token-based indexes, which allows for searches to be done by the tokens themselves. So as you can see here in this example, you can do a single token, you can AND multiple tokens, you can do a combination of ANDs or ORs or just ORs. So if we look at the traditional brute force way of doing things, and again, this is just how everybody else in the industry sectionally does classic regex searches, is you need to look at things line by line, character by character. So in this example, we're looking for John, and because we don't know if John is spelled with a capital or lowercase letter, we have to accommodate for either of those. So we have an OR. So what it'll do is we have to read every single line. So if you've got 1,000,000 lines of logs, you have to look at every single line of log, all 1,000,000 of them, find which ones match the regular expressions by comparing each character until you get the result set that you found where things have matched. So in this example, you can see here, this is the regular expression tree here. So for the regular expression that we defined for this particular sample. So you'll see the decision tree here. It had to consume quite a bit of the logs before it got to the decision tree. And then it has to branch out and make each and every distinction for every character to find whether the pattern is matched. So this itself lends to be very powerful and flexible, but yet not very efficient. So accelerating regex queries with token-based indexes. So regular expression queries excuse me, can be accelerated with tokens indexes by combining the regex and the indexes together, all in the same query, all seamlessly. And again, this is what we demonstrated with our advanced search. So the system applies the regex first, then the regular expression on the result set. This is all done seamlessly and transparently, as you've seen. This allows for, again, for faster regular expression search by working across smaller result sets. Now, this is not good for all cases, and we saw that in our last example. So, there's things where they can prove kind of false positives, and where the regular expression and the combination of indexes allows you to be more exact and more precise. So let's take a further look. So here in this example, and again we saw the same example in our demo here previously, we know that these two are tokens. So if we look at these two, they're tokens. So the token index will essentially take these two tokens, the event ID and then the string. It'll fly the logs across it. It'll find things in the tokens that match. Then what you want to do is you've got to run the regular expression on top of that so that you get a more precise match. In comparison to the brute force regular expression, where we apply the string itself, again, because it's got to read every single line of log plus every character, it takes a long time before the result sets are known and you finally get to a match. So can we determine the tokens automatically? In some cases, yes. So when you look at these, you can see that, with this first example, we don't know exactly what comes before or after the tokens. In this example, we know that there are spaces before and after the terms, so then we know they can be indexed. We already know that spaces are a boundary for a token index. Here we can see it in context. So here you can see that the event ID 4625 does indeed have a space before and after it. Same with the account name. So we know that this can be tokens. So we can leverage the token index for faster search. So for regex queries to be accelerated, we need to add a token as a part, add the token part separately, right? So in this example here, we're using our SQL syntax for advanced search. And again, what we're looking for is here, we're searching across all the Microsoft events where we find in the message any of these two tokens. So 4265 followed by the string. Then we apply the regular expressions itself here across the result sets. So in summary, fast queries require token indexes. Token index accelerated regular expression queries provide better search performance, as we saw there with our advanced search. So let's take a look at this case. We did some benchmarking here. So for 31 million rows in one day, all windows generated, we had applied this string here. It took us about 5 minutes 30 seconds in the traditional regex report, but it only took us 5 seconds in the new advanced search. This same thing here, we're looking for an insensitive match for a domain name. Again, about a little over 5 minutes, and then only in 4 seconds in our new advanced search. For 39 million rows of one day, each day that is, for web access for with real IPs rather, and IPs that are anonymized, we saw this example here, where we're basically ORing 3 IP addresses the brute force way, and it took 2 minutes, whereas the new advanced way only took 4 seconds. We returned 453 matches. Again, when we got to more complex queries with sparse data, where we're looking for essentially some HTTP log traffic here, so gets followed by a string and then an error, the brute force way took about 2 minutes, whereas the advanced took about 1 minute. So again, we know that the advanced search is much faster and more efficient. So thank you. This ends our presentation.